Welcome to a brief presentation on easy-to-use thermal management for printed circuit boards. We will show you how the Pulsonix design tool and the TRM simulator work together to predict hotspots and nets with high current density. There are many options and physical effects available. Here we can only give you a brief overview. We'll start with how to add physics to Pulsonix and how to export the design to the TRM simulator. Open the Attribute menu. Create a TRM Power attribute and enter the wattage of the components you want to examine. Create a TRM value attribute and enter the amperage or voltage for the relevant pins or nets and signals. The export is completed in a few seconds. Now let's move on to the TRM simulator. The Pulsonix data gets read in via the TRM import wizard. No time-consuming finite element meshing is required. The data is displayed in easy-to-understand tables and menus. Usually, the watts or amps are changed or updated here to answer the final questions. Define your ambient cooling conditions and start the calculations. The results are available within a minute or 2 to 3 minutes at the latest. There are 2D and 3D representations. Here we see the voltage in calculated nets. This is the corresponding current density. And this is the surface temperature of top and bottom layer. Using the import option on the TRM bar, it is also possible to bring the results into Pulsonix and perform other types of checks. Display the voltage using the probe and a head-up display. Display the current density using the probe and a head-up display. Display the temperature using the probe and a head-up display. I will show you for the top and the bottom layer. We have not discussed time-dependent settings, other types of boundary conditions inside and outside the board. These and much more can also be performed or analyzed within the TRM product. Ask Pulsonix for more details, a test installation, and licensing options.